The universe has a beginning, but does it have a final event? Not just a slow fading or endless expansion, but a single ultimate moment that ends everything completely. Scientists have long debated how the cosmos might end. Among all possibilities, there could exist one final event so powerful and absolute that it erases all structure, all energy, and even the rules that define reality itself. One candidate for this final event is the heat death of the universe. Over trillions of years, energy spreads evenly across space. Stars burn out, galaxies fade, and motion slows. Eventually, the universe reaches maximum entropy, a state where no useful energy remains to drive change or create new structures. In this state, nothing dramatic happens. No explosions, no collapse, just stillness. The universe becomes cold, dark, and silent. Particles drift in isolation, and interactions become extremely rare. It is not a violent ending, but a quiet, inevitable one. However, some theories suggest a more dramatic conclusion. The Big Rip scenario proposes that dark energy grows stronger over time. As expansion accelerates, it could eventually tear apart galaxies, stars, planets, and even atoms, ending everything in a violent cosmic destruction. 5. In the Big Rip, the timeline accelerates toward the end. First, galaxies separate, then star systems collapse, then planets are torn apart. In the final moments, even atomic bonds break, and matter dissolves into fundamental particles. Another possibility is the Big Crunch. If gravity eventually overcomes expansion, the universe could begin collapsing inward. Galaxies would merge, temperatures would rise, and everything would compress into a dense, hot state similar to the conditions at the beginning of time. The Big Crunch represents a dramatic reversal. Instead of spreading out, the universe gathers everything back together. As matter compresses, energy increases, leading to extreme conditions where physics as we know it breaks down. Black holes also play a role in the universe's long-term fate. Over immense timescales, they dominate the cosmos. Yet, even these objects are not eternal. Through Hawking radiation, they slowly evaporate, releasing energy back into space. When the last black hole disappears, one of the final sources of energy vanishes. At this point, the universe is left with only low-energy particles and radiation, drifting in a nearly empty expanse. Another theoretical ending involves vacuum decay. If the universe exists in a metastable state, a sudden transition could occur. A bubble of low-energy vacuum would expand at the speed of light, rewriting the laws of physics and destroying everything instantly. Unlike other endings, vacuum decay would happen without warning. There would be no gradual change, just a sudden shift where reality itself is replaced. This could be the true final event, instantaneous and absolute. Time itself may also come to an end. If the universe reaches a state where no events occur, the concept of time loses meaning. Without change, there is no way to measure time, and the flow of moments effectively stops. In all these scenarios, structure disappears. Galaxies, stars, and planets cease to exist. Even the smallest particles eventually decay or become isolated beyond interaction. The final event is not just about matter disappearing, it is about the end of processes. No reactions, no movement, no evolution. The universe becomes static, frozen in its final state. Some theories suggest that this ending could lead to a new beginning. A collapse or quantum fluctuation might trigger another Big Bang, creating a new universe from the remnants of the old one. The final event that ends the universe completely may never be witnessed, but it defines the ultimate fate of everything. Whether it arrives as silence, destruction, or transformation, it represents the last chapter in the story of the cosmos, a moment where existence itself reaches its absolute end.